Electric vehicles are a reality, and scientists are now looking ahead. They're exploring new frontiers to make them safer, more reliable, more autonomous, and more affordable. And as you're about to see in this report, European researchers are not short of ideas to address all these issues. So fasten your seatbelts and join us on a ride on the electric mobility of the future. So to start, an electric vehicle that, according to its developers, has been designed to suit all tastes. And not only because its solar cells feed its electric batteries, but also because the vehicle itself is able to provide some food. What are microwaves and frying pans doing in the rear of this electric car? Where's the luggage? These scientists are loading some unexpected research equipment on a prototype just developed at this Italian lab. What is this car?
This is an electric restaurant car. We wanted to show that by just using photovoltaic energy, you can not only drive the vehicle, but also power a kitchen and be able to cook in an ecological way.
The prototype's been designed by scientists at a European research project aimed at exploring new, innovative ways to design and produce modular urban light electric vehicles. This tiny food truck's the latest newcomer in a game that also includes small pickups, vans, or even taxis. They all share the same concepts for chassis, the powertrain, and energy-driven technologies. What were the main mechanical and electrical challenges to develop this prototype?
Our car is modular. We always have the same chassis based on a mix of very high resilient steel. The car has 4 powered wheels. It has 2 motors, one in the front, another in the back. Each motor feeds 2 of the wheels.
These modular cars have been designed with simple elements to simplify assembly and reduce costs. But they'll have to be as safe as any other vehicle on the market. So researchers have had to turn to new solutions for its conception.
We are talking about very small cars, so we have much less space to absorb energy. So we decided to use a special steel. It's a very elastic steel, really innovative. Its biggest advantage is that this steel absorbs big quantities of energy.
The car's 2 motors were made with magnets instead of rare earth materials to reduce costs. Each motor delivers 9,000 RPM to the wheels, according to its developers.
Requirements for this kind of electrical traction are basically high efficiency, high power density, and constant speed. This is what we tried to develop. The fact that the car has 2 motors offers some advantages. 2 motors gives more flexibility to the vehicle, and it improves its acceleration performances. These are the main advantages.
And researchers are now testing the model's reliability and ergonomics. Details like visibility, handling, onboard sensing or computational power are closely studied at these labs.
Our aim was to develop a really high-tech vehicle with state-of-the-art technology that has the safety of a plane and for the cost of a washing machine. In the 90s, the big challenge for technology developers was bringing a cell phone into every home. Our challenge now is to bring one of these cars to the garage of every European.
And while continuing to work on sometimes tasty validation tests, researchers say they're now getting ready for the next big step. When do you think this car will be ready for manufacturing?
Our idea is the manufacturing should be tailor-made. Tell us where you want to produce the cars. We come with our trucks with containers. Inside the containers you have robots ready to assemble the car. So in just a few days you're able to produce electrical cars that we consider safe, reliable and efficient. Vehicles that are only powered with renewable energies.
Researchers hope their modular vehicles could be ready for industrial manufacturing in less than 2 years. And how to guarantee the safety and technical reliability of these existing and future electric cars, and also their charging points. Those are the questions that European scientists are addressing from this sophisticated lab in northern Italy. The lab includes this electric and hybrid vehicle testing facility, a climatic chamber with temperatures ranging from -30 degrees centigrade to +50 degrees under controlled humidity. Researchers are able to get information about the car's performance and efficiencies under different drive cycles and climatic conditions, including the impact of heating, ventilation or air conditioning.
We measure information on electrical data, information on the ratio between the car's emissions and its consumption. We also obtain information about the car's own consumption of electricity and how its battery behaves.
The labs also include a new chamber designed to analyse electromagnetic emissions generated by electric cars during acceleration, driving and braking. Researchers use reception antennas and receivers to measure e-mobility's potential interference with communications frequencies. They can also test the immunity of electric vehicles against external electric and magnetic fields.
Why is it important to measure the magnetic fields around the vehicle?
Es gibt in diesem ja noch sehr jungen Feld der Elektromobilität.
Electromobility is a very young field of research, and it involves technical equipment where certain fears need to be addressed, and methods need to be developed to rule out problems in the future with certainty.
Schwierigkeiten in Zukunft mit Sicherheit ausschließen zu können.
These include, for instance, very low-frequency magnetic fields in the fast charging area, which could, under certain circumstances, pose a risk for pacemaker patients. And of course, we want to exclude such issues from the very beginning.
Ein Risiko bedeuten könnten, und das wollen wir natürlich von vornherein ausschließen.
Research is complemented by testing the interoperability of all supply devices and communications systems involved in electric car recharging. Researchers study evolving smart power grids integrating renewable sources of energy, electric vehicles, storage and other features.
Take, for instance, a future mobile app that will allow us to book a charging point for our electrical car. So you book it, you drive there, you recharge your car, and you leave with your battery totally full. This may look like a very simple process. It takes just around 30 minutes to do all that, but it needs between 10 and 15 different agents, systems and components that must all work together in real time. This is very complex, and this is what we are trying to ensure in our labs, that all these different technical components work well together.
Information acquired at these facilities should make the establishment of standards and harmonised criteria easier to guarantee safety and reliability in future electric vehicle and recharging markets. Ecological and more sophisticated electrical vehicles make some people dream, and yet their limited range is a huge challenge. Most existing vehicles on the market still can't go very far on one charge. It's a challenge that some European scientists say they're addressing with the help of this trailer. Researchers here have developed a portable generator housed in a little two-wheeled trailer. It can be programmed with a mobile app. The generator produces energy to bolt on to the electric cars to increase their range. The energy is provided by petrol.
If you're doing 100 on the highway, an average electric car offers you around 100 kilometres of autonomy. With our prototype, you can drive 500 kilometres. Then you fill up with petrol and you keep on going.
Is it not a curious paradox that at the end of the day you need petrol to produce energy for an electric car?
Yes, it's a paradox, but over the year you're going to drive mostly short distances, so short trips you drive with your batteries, but if you want to do 500 kilometres you use our product powered with petrol. But how often do you do long trips? 3, 5, 10 times a year?
The trailer's around 1.2 metres long, it weighs some 250 kilos and provides a peak power of 20 kilowatts. And scientists say it has some sophisticated electronics on board.
We had to find the right processor and the right systems, and then we had to make sure that the algorithms that we had imagined on paper worked in the real product.
Production of the first units was done at this small French company. Researchers here say the product is fully ready for industrial assembly lines after multiple manufacturing challenges were sorted out.
This is a complex product with a combustion engine and power electronics in a very small closed environment. There are very different components with really complex functions, and this reality imposes important constraints for the mechanical integration of the product.
Back on the road, the trailer's developers are already working on a business model based on a rental basis, they say.
You don't want to add a motor to each electric vehicle. Maybe there will be one trailer for every 10 or 20 electric cars, and so you will just rent it when you need more range.
What prices are we talking about?
If the driver wants to drive just for one day and the motor works for 1 hour, rental price would be 17 euros. Each other extra hour you pay 7 euros. So if you're renting the trailer one day and the motor works for 3 extra hours, that's a total of 38 euros.
Researchers say they expect the product to hit European roads in less than 3 years.